In the previous video, I introduced you to the idea of oscillation. We can define oscillation as a self-sustaining repeated motion. Examples of oscillation, as I gave in the previous video, are a mass oscillating up and down at the end of a spring. The other example I gave you was pendulum motion. In the motion of a simple pendulum, we have a mass attached to a string, and then the string is connected to a fixed support up here, and then the mass oscillates back and forth at the end of the string. In this video, I'm going to introduce you to two key quantities that we use to describe oscillatory motion. The first of these is the period. The period of oscillation is the time needed for the oscillating system to complete one cycle of motion. The symbol we use for the period is this symbol here, which is the Greek letter tau. The other quantity I wanted to introduce you to is the frequency of oscillation. The frequency of oscillation is the number of cycles of motion per time. As an example, let's say that we have a mass oscillating at the end of a spring, going down, up, down, up, down, up, down, up. Each time the mass starts at the top of its motion and then goes down and then back up, returning to the original position, that would be one cycle of motion. Now suppose that this mass completes 3 cycles of motion in 1 second. In other words, let's just say the mass goes 1, 2, 3 like that, and the whole thing took 1 second. What would be the frequency of this motion? And what would be the period of this motion? Why don't you pause the video, try and fill in values for each of these, and once you've given that a shot, rejoin the video. Well, if the mass completes 3 cycles of motion in 1 second, then the frequency, which is cycles of motion per time, would be 3 cycles per second. And normally, we would not write out the word cycles. We would just say 3 per second like that, or 3 over seconds like that, or 3 times seconds to the minus 1. So that frequency of 3 cycles per second can be written in any of those ways. You would generally not include the word cycles. Now, what about the period? The period is the time needed to complete 1 cycle of motion. So if the mass completes 3 cycles of motion in 1 second, the time to complete 1 cycle of motion would be 1/3 of a second. So that would be the period. Normally, we would not write that as a fraction. We would write that as a decimal out to some decimal place and then round off. So the period would be 1/3 of a second, or 0.33, however many threes, seconds. Now, what is the relation between frequency and period? Or I could ask, what is the relation between 3 and 1/3? In this specific example, you can see that the period is the reciprocal of the frequency. But for that matter, the frequency is the reciprocal of the period, and this would generally be true. So anytime we're talking about an oscillation, the frequency and the period would be reciprocals of each other. We can then write frequency equals 1 over period. Here's a quick example to drive these ideas home. Let's say that this is the surface of a lake, and we have some wave propagating along the surface of the lake. We have a ping pong ball, which is floating on the surface of the lake, and as this wave goes through, the ping pong ball is going up, down, up, down, up, down, up, down, like that. So let's say we want to find the period of the motion and the frequency of the motion. So why don't you pause the video and give that a shot, try and work out the period and the frequency, and then rejoin the video. First, the period. It takes 10 seconds for the ping pong ball to complete 4 cycles of motion. The period would be the time for 1 cycle of motion. So if 4 cycles takes 10 seconds, then 1 cycle would take 10 seconds divided by 4, or in other words, 2.5 seconds. Then what would be the frequency? The frequency would be the reciprocal of the period, or in other words, frequency would be 1 over 2.5 seconds, which we could write as 0.4 cycles per second, or if you prefer, we could say that the frequency is 0.4 seconds to the minus 1. Okay, so now we have had a quick introduction to the concept of oscillation and then to the ideas of frequency and period. Now, starting with the next video, we're going to be taking a deep dive into the archetypal example of an oscillating system, mainly a mass oscillating at the end of a spring.